All right, this is the last section of the first part of chapter 4. So remember, I broke chapter 4 up into parts because it's a long chapter. And after this section, we're going to have a test on what we've learned so far in 4.1 through 4.3. So today we're talking about multiple derivatives. And you're going to see as we move on throughout the year, there's certain times when you want to take the derivative more than once. Meaning like you take the derivative and you get your answer, and then you take that answer and you take the derivative again. That's called a multiple derivative. And I want to start by mentioning the derivative. What we've just called the derivative so far is technically the first derivative. That would be the technical name for it. And then from there, I might ask you to find the second derivative, which means basically take the derivative twice. You take your function, you take the derivative, you get that answer, and you take the derivative again. I could also ask you to find the third or fourth or fifth derivative. If I ask you to find the 10th derivative, then you take the derivative 10 times, and you're just chaining your work. Each time you get an answer, you take the derivative of that answer. Now, as far as notation goes, for the lower ordered ones, we're basically just going to add apostrophes. So we already know that f prime of x, or the apostrophe, one single apostrophe, means the derivative of f of x, or the first derivative. So here's a new notation for you guys. If I do an f with two apostrophes after it, we say f double prime of x, and that means the second derivative, or basically the derivative of the derivative. Three apostrophes would mean the third derivative, and we would say f triple prime. Now, once you get past 3, you don't just keep adding up. It would be like if we're doing the 10th derivative, it would be kind of weird to have to count. How many apostrophes is that? 1, 2, 3, 4, 5, 6, all the way to 10. So there's two ways. Once you get past 3, there's two common ways of doing it. Number one, you might use Roman numerals. And Roman numerals is like capital I means 1, capital V means 5, capital X means 10. You can kind of combine them, or if you put one of them, if you put the I in front of the X, it's subtraction. That's Roman numerals. Or you can do what our book does and actually just put a number in parentheses. So here's an example. If I were asking you to do the fourth derivative, I might do f with Roman numeral 4, which is capital I, capital V of x. Or what our textbook does is the second one, where it just says, and it's this one right here, this is the one our book does. So if you're looking at the homework and it's asking you to find the fourth derivative, it's going to say find f, and up in the derivative part, it's going to be the number 4 in parentheses of x. And then it keeps going from there. So, like I've been using the 10th derivative, although I probably wouldn't ask you to find that. The 10th derivative would be this, basically. F, number 10 in parentheses, of x. That would be basically asking you to take the derivative 10 different times and tell me what the answer finally is after all of that. All right, so we understand what a multiple derivative is. Now the good news here, you're not learning how to do a new question. You're just doing a question you already know how to do, but repeatedly. And now that you know the notation, we can try a couple out. So I gave you a function for this example. I said f of x equals x over x plus 1. And I asked you to find f double prime. So you look right here and you notice there's two apostrophes there. Now I want you to realize as soon as you see this set up for a question, just realize I am asking you to do two completely separate questions. Part 1 is find the derivative. That's going to be f prime of x. Once you get that answer, do it again and find f double prime of x. So let's find f prime first. All right. Now this is definitely going to be quotient rule. We just learned quotient rule in our last section. This is quotient rule because it's a fraction and because you have a function of x both on top and bottom. So there's really no way to get around this. This has to be quotient rule. So as a rule, as a review for quotient rule, the first thing you always do is take whatever's on the bottom and square it. So I take my x plus 1, square it. Now for the top of the quotient rule, it looks just like product rule, but it has a minus instead of a plus. So you can kind of use these fill in the blanks here. And it's derivative of the top times the bottom, which is x plus 1, minus the derivative of the bottom times the top. So I always like to do that. I like to fill in the ones that you don't have to do any work. Now I'm going to do the derivatives to fill in those last two blanks. So in the first fill in the blank is the derivative of the top function. Now the top function is just x, and the derivative of x is just 1. And in the second blank, the derivative is actually also going to be 1. Because see, for my second blank, when I'm doing the derivative of the bottom, the derivative of x plus 1 is also 1, because the derivative of x is 1, and the derivative of 1 is 0. It basically disappears. So what I get here is, if you distribute the 1, you just get x plus 1. We have minus 1 times x, which would be minus x, and it's all over x plus 1 squared. Now the x and the negative x on top will cancel. So for my final answer, remember this is f prime of x that I just found, you get 1 over x plus 1 squared. Now I'm going to stop and completely restart the question. I'm going to find the derivative of that, of exactly what you see. My new question is find the derivative of 1 over x plus 1 squared. And once we have that, that'll be the answer to the question. It'll be the second derivative. Now I'm going to do one more thing here. When you're looking at what we have for f prime right now, your initial thought might be, hey, it's another fraction. I'm going to do quotient rule again. But remember, when you have just a 1 or a constant on either side of the fraction, top or bottom, you don't need to use quotient rule. You can, but it would actually be more work. So I'm going to go one extra step here on f prime of x. And instead of writing it as 1 over x plus 1 squared, I'm going to write it as x plus 1 to the negative 2. And then I'm going to do power rule on it. So let me move off to the side here, and I'm going to find f double prime of x. So what I'm going to do is, and I'm going to use a little trick here. I'm actually going to use something called the chain rule, which we're going to use next. We're going to learn next. And you haven't learned it yet, but I'm going to kind of work around it and explain, why we're allowed to do it right now. So basically what I have is, in fact, let me do this. Let me start by just recopying the problem here. We have x plus 1 to the negative 2. And when I go to take the derivative of that, that's going to give me f double prime. Now, what I'm going to do, even though we have something in parentheses, I'm going to do power rule on it, meaning I'm going to multiply by negative 2, and I'm going to lower the exponent to negative 3. Now, there is something involved here called the chain rule, but it doesn't really apply to this question because the derivative of x plus 1 is 1. It's very simple. So we'll talk more about that next section, but for now, just kind of trust me, it does work here. But to finish out this question, what I might do, I don't really have to, but what I might do is just rewrite this, take that negative exponent and put it back as an x plus 1 cubed in the denominator, and that right there is your final answer, negative 2 over x plus 1 cubed. But what you can see when you're doing these multiple derivatives, all you're doing is a derivative question, which you know how to do already, but more than once. So in white, down there along the left, I took the derivative. I found f prime. And then in yellow, I took the derivative of my answer, which then gives me f double prime. All right, let's do one more example and we'll be done. There it is. Okay, so what I'm asking you guys to do, if you look here, is find the fifth derivative. But we don't have to take the derivative 5 times because I started you with the second derivative. I said f double prime of x equals, and then I gave you that function. So what we're doing is we're part of the way through the problem already. If I want to find the derivative of f double prime, when I do that, it will give me f triple prime. So right here I have f triple prime of x. Now I'm going to take the derivative, and you can see right off the bat, this question, the derivative work is going to be way more simple than the last example. The last example we had to do quotient rule. This one's just power rule. So for each one of these, I'm going to multiply and lower the exponent by 1. So that would give me 4x to the third, plus multiply 9, lower the exponent to 2, 9x squared. And then for the last two terms, it's not even power rule. The derivative of negative 7x is negative 7. And the derivative of 15 is 0. I'm just going to leave it off. So basically, f triple prime, the third derivative, is 4x cubed plus 9x squared minus 7. All right, well, let's take the derivative again. If I take the derivative of f triple prime, I get the fourth derivative. And it's power rule again. So I'm going to multiply the exponents. 3 times 4 is 12. Lower the exponent by 1, 2. Power rule again. Multiply by 2, you get 18. Lower the exponent by 1, you get x to the first, or just x. And this time the 7 disappears. All right, one more time and we're done. So the fifth derivative of x, which is going to be my final answer, power rule again. 2 times 12 is 24. Lower the exponent by 1, you get x, or x to the first. And the derivative of 18x is just 18, because that was x to the first power. So here's your final answer, 24x plus 18. We ended up taking the derivative 3 times, because I started you with the second derivative, and I asked for the fifth derivative. So to get there, we took the derivative 3 times, but each one was a nice simple question. It was just power rule. All right, so that's multiple derivatives. Remember, the main idea is we're not learning how to do a new problem today. We're taking problems we already know how to do and just doing them more than once in each question.